always see the same face of the moon. That happens because the moon is a cosmic plasma phenomenon. The moon is not land, but a focused electromagnetic energy light with its own phases. It takes place in a semi-ethereal toroid field above because of the electromagnetic energy that comes from below our level plane. On the face of the moon, we can see the material field that is below the world that we live in, mirrored, working like a level Earth's selfie. The moon is focused electromagnetic phenomenon called plasma. Cosmic electromagnetic energy comes below from the flat and stationary plane going above. The inner reflection of this electromagnetic energy on this field's ceiling turns it back down, creating a focus spot point in a semi-ethereal environment. At this spot, there is fluorescence of the ether because of the focused cosmic electromagnetic energy. The spot that is created is the moon. In this way, the moon reveals to us the large part of the terrestrial and oceanic surface, and with these natural characteristics, serves as a natural map of Earth. Moon, the map of Earth. Moon is a focused plasma phenomenon and happens in the ethereal field above. It is a semi-ethereal, showing us the material field and the world we live in. The reason that happens is an electromagnetic coil moving source below. With a few words, is like Earth's selfie. It is the mirror of the Earth. That is why we always see the same face of the moon. It is the face of the Earth in real time. We have to flip the moon mirror and to see the map of the Earth in this transition. Water masses and energy spots give fluorescence on the ethereal field above, white areas of the moon. But land masses do not, transparent areas of the moon, blue in the day, black in the night. So in this way we have the first world map by plasma moon. Water masses give fluorescence in the ethereal field above and create the Moon. They are represented from the white part of the Moon. Land masses do not give fluorescence, so they are represented transparently. They always take the background color of the sky. Moon is an electromagnetic phenomenon and happens in a semi-ethereal field above at around 5,500 kilometers altitude. Its diameter is 51 kilometers. It is made from fluorescence and phosphorized ether of krypton. Cosmic electromagnetic energy comes from below, black sun, and hits the inner side of our toroidal field. There is a prismatic refraction of this cosmic energy there that separates it to plus and minus, creating the Sun and the Moon at two moving spots with shape-like lenses below where they are focusing. The Moon is a live reflection of the Earth like a mirrored X-ray. In this way it reveals to us all part of the terrestrial and oceanographic surface of the Earth. These characteristics serve as the full map of Earth. Sun and daylight. The Sun is the pilot light of the daylight and is also semi-ethereal, on the same height with the same size as the Moon. It happens because of an electromagnetic coil moving source below. The ionosphere is the upper portion of the atmosphere. There are the inert or noble gases that are separated on layers according to their molecular mass. Sun happens above these layers in the ionosphere, and it is the pilot light, electromagnetic field, and due to this light there are shadows. It gives direct light. The Sun creates and also moves a curved electromagnetic field around it that makes all the inert gases below in the ionosphere around the topical Sun to react by being ionized, giving fluorescence. That is exactly the daylight. Happens in the ionosphere and is called plasma light. It is a circle-moving fluorescent molecules light umbrella over level Earth made by ionized inert gases. Daylight is gas discharge light in a huge scale. When the Sun goes away, the temperature and the pressure are getting very low and the gases there are discharged. When the Sun comes, the electromagnetic field ionizes the inert gases and we have daylight. If something occurs, it is not the Earth but the daylight, because it happens due to the pilot moving electromagnetic field that the Sun creates. We also see noble gases helium, neon, argon, krypton, xenon, also hydrogen. These gases are the gases of the ionosphere and they are on layers, everyone in a different layer, the heavier gases down and the lighter up. A moving light umbrella is the daylight called plasma. We can see every color from the ionized gases in the sky. Every blue from ionized argon is the blue color of the sky. Every yellow-orange from ionized neon is the color before sunrise or after sunset. Neon reacts from long distance with a less electromagnetic energy. Sun is an electromagnetic phenomenon and happens in a semi-ethereal field above at around 5,500 kilometers altitude. Its diameter is 51 kilometers. It is made from fluorescence and phosphorized helium. It is the pilot source of electromagnetic energy, giving it to the other inert gases below, neon, argon, krypton, xenon, and radonium, charging them. These charged gases are responsible for the colors of the daylight. Cosmic electromagnetic energy comes from below and hits the inner side of our toroidal field. There is a prismatic refraction of this cosmic energy there that separates it to plus and minus, creating the Sun and the Moon at two moving spots with shape like lenses below where they are focusing. The ionosphere is the upper portion of the atmosphere. There are the inert or noble gases that are separated on layers according to their molecular mass. Sun happens above these layers in the ionosphere, and it is the pilot light electromagnetic field, and due to this light there are shadows. It gives direct light. The Sun creates and also moves a curved electromagnetic field around it that makes all the inert gases below in the ionosphere around the tropical Sun to react by being ionized, giving fluorescence. The moonlight is colder than the shadow. Doing the experiment to measure the temperature at a point that receives the moonlight and a little next to it that has a shadow, we find that the thermometer in the moonlight shows a lower temperature. Depending on the light of the moon, which depends on the phase it is in, but also on other factors such as the purity of the atmosphere and the temperature, we have the corresponding cooling, with the full moon giving the greatest. This happens because moonlight is a different light than the sunlight. The moon does not reflect the sun's light, it is an independent one. Total cosmic energy comes from below and hits the top of our electromagnetic toroidal field. Two conical energy and light refractions happen there that create the sun and the moon below where they are focusing. The sun is the focused energy plus and the moon is the energy minus. That is why we measure the light temperature of the moonlight is colder than the shade. the surface of the Earth, there is the black sun that is responsible for the creation of sun and moon. Polar lights are from the black sun below and come from a big hole that there is on the magnetic north in Hyperborea. Black sun is moving below in a coil motion, creating an electromagnetic field with direction from below to above. Its motion center is magnetic north. Polaris is fixed and is up from the magnetic north. On the top of the ceiling of our toroidal field, black sun's electromagnetic field creates the stars as reflections of the great depths and energy spots of Earth. The diameter of black sun's motion is changing, a fact that makes all the electromagnetic field dynamic. On our toroidal ceiling, at the place where Polaris happens, there is a reverse direction refraction of the cosmic energy that comes from the black sun. This refraction separates the cosmic energy to energy plus that creates the sun and to minus that creates the moon below where the refracted energies are focusing. The plus refraction of the cosmic energy works like a limit to the minus refraction when these refractions are close. Because of this, we have the phases of the moon. That's why there is a relation between the constellation difference between the sun and moon and the moon's phases. When the conical shape refraction that creates the sun plus is on the same constellation as the refraction that creates the moon minus, the first one neutralizes the second. In this way we have the new moon. Because of the dynamic of the refraction, every day there is a different position between these two conical shape refractions, and in this way we have the moon's phases. When these refractions are opposite, there is no neutralization of the moon's conical refraction from the sun's one, so only in this case we have the full moon. As the sun's refraction is getting closer again, we have the rest of the moon's phases till the new moon. When the angle of incidence of the black sun below is big, the sun and moon are very close. When they are at the same constellation, we have the new moon. In this case, the conical refraction of the sun completely neutralizes the moon's one. As the angle of the incidence is getting smaller, we have the first quarter of the moon. In this case, the sun's conical refraction hides the half of the moon's refraction from left, if we are northern, the moon's path, or right if we are southern, when the axis of moon's phases is vertical to the horizon. When the angle of incidence is the smallest, we have the full moon. In this case, the two refractions are opposite and do not affect each other. Finally, when the angle of incidence is getting bigger, we have the third quarter, and in this case, the sun's conical refraction hides the right half of moon's refraction when the axis of phases is vertical to the horizon, when we are northern, the moon's path, or the left if we are southern. Constellation circle. The real constellation circle has not its center in the middle. If we put the constellation center of the moon, the map of the Earth, in exactly the same diameter, we can see that the North Pole is at the same place of the constellation circle. The center of the constellation circle and the North Pole makes a full circle too, every 26,000 years. Moon's phases. Moon phases depend on the constellation difference between Sun and Moon. There are 13 moons every year. The changing angle of the electromagnetic field below that creates the Sun and the Moon is the reason for the moon phases. The shading we see in the craters of the Moon changes, and this fact is depending on the Moon's phase. The Moon is a concentrated semi-ethereal phenomenon that shows the Earth's surface due to the cosmic energy that comes from below. This cosmic energy is refracting to the ceiling of the field, creates two luminaries, the Sun and the Moon, below where they are focusing. The Moon is like the X-ray of the Earth imprinted on the ethereal field above. The phases have to do with the conical refractions that are created, Sun and Moon. When the refractions are close, in constellation circle, then the refraction plus neutralizes the reflection minus. Commonly, the Moon has a limit, and this is the conical refraction of the Sun. What we see as a crater is the shape of the terrain of the Earth on a deep ocean at that point. The change of the shading angle of the craters, depending on the phase in which the Moon is, shows us the angle of the incidence from bottom to top of the cosmic energy from the black sun phenomenon. Constellation difference, Sun and Moon. There is a relation between the Sun's and Moon's constellation difference and the phase of the Moon like this. New Moon. When there is a new moon, the Sun and the Moon are in the same constellation. When the angle of incidence of the black sun below is big, the Sun and Moon are very close. They are at the same constellation and we have the new moon. In this case, the conical refraction of the Sun neutralizes completely the Moon's one. These conical refractions create the Sun and the Moon with shapes like lenses at almost same altitude. First quarter. In the first quarter of the Moon, the Sun and the Moon have 3 constellations difference. As the angle of incidence is getting smaller, we have the first quarter of the moon. In this case, the sun's conical refraction hides the half of the moon's refraction from left if we are northern, the moon's path, or right if we are southern, when the axis y of the axis of phases is vertical to the horizon. Full moon. When there is full moon, the sun and the moon are in opposite constellations. They have 6 constellations difference. When the angle of incidence is the smallest, we have the full moon. In this case, the 2 refractions are opposite and do not affect each other. Last quarter. In last quarter, the sun and the moon have 9 constellations difference. Finally, when the angle of incidence is getting bigger, we have the third quarter, and in this case the sun's conical refraction hides the right half of moon's refraction when the axis of phases is vertical to the horizon, when we are northern, the moon's path, or the left if we are southern. We can study oceanographia looking at the surfaces of the bottoms of the seas and great depths. Craters of the Moon are great depths, big holes, and deep canyons at the bottom of the seas of the Earth. Their shape gives us information about heat treatment that the base of the Earth created.
Just walk through that door. Sometimes I feel like I wanna fly, reach out to the painted sky, a prisoner to the wind, a bird on the wing. Like the warm rush you get from black opium, black opium.
Stars. On the Moon, we can see the entire sky with all stars, galaxies, and constellations. They are a reflection of the great depths of the seas and energy spots of the entire Earth on the ethereal field above. Great depths and energy spots are reflected on the ethereal field above. These are the stars and the constellations. Every place on Earth is a place in the sky. This reflection is not focused so we can see only one part of the whole sky, Earth. The stars are the reflections of the great depths and energy spots of the Earth on the ethereal field above. Every great deep, continually great deep places like abysses or canyons or energy place is reflected above. Every reflection is a star, being a part of a constellation. Looking at the night sky, we can see a part of the map of the great depths and energy spots. Every energy spot or great deep place corresponds with a star. The real constellation circle does not have its center in the middle. If we put the constellation circle on the Moon, the map of the Earth, in exactly the same diameter, we can see that the North Pole is at the same place of the center of the constellation circle. Planets as toroidal fields. Planets are ethereal toroidal fields, one inside the other. Every field gives an imprint above, just like the Earth on the Moon, showing us the ethereal fields that include the material field we live in. In this way, we can see the 7 ceilings of the ethereal fields that we are included in. Each field reflects its cosmic energy on its ceiling where it is visible. Each outer field contains its own means under certain conditions. Uranos is the outermost and largest ethereal toroidal field in which there are all the other ethereal fields, what we call planets. What we see is the imprint of all the fields that make up the field of Uranos, above on the Uranos field's ceiling that is the last known as the 7th ceiling. Saturn, Kronos, is an ethereal field that includes more ethereal fields under specific circumstances. Saturn's ethereal field gives an imprint its toroidal field ceiling, and that is what we see. Saturn field includes Jupiter field with 4 energy satellites. The rings of Saturn are the ethereal imprints of Jupiter satellites on Saturn's field ceiling. Inside the rings of Saturn is Jupiter imprint of Saturn field ceiling. This energy ethereal imprint happens on the 6th ceiling. Jupiter is an ethereal field that includes more ethereal fields under specific circumstances. Jupiter and its energy satellites are included in Saturn's ethereal field. Jupiter's satellites give their imprint on Jupiter field ceiling. We can see Jupiter's satellites like Saturn rings, one field ceiling above, on Saturn field ceiling like the rings of Saturn. Like a photo of Jupiter with its satellites with open aperture. On the 6th ceiling, we can see them like a ring, and on the 5th ceiling, like satellites. Jupiter ethereal field gives an imprint to its toroidal field ceiling, and that is what we see. Jupiter field also includes Mars ethereal field under specific circumstances, and we see it like a red dot marking circles inside the Jupiter field on a level. This imprint happens on the 5th ceiling. The ethereal toroidal field of Mars is contained within the much larger field of Jupiter under certain conditions. It is the red spot contained in Jupiter and can be seen in the imprint of Jupiter of the 5th ceiling. The field of Mars that contains Venus and Mercury fields is reflected on the ceiling of this field of the 4th ceiling. The ethereal field of Venus is included with that of Mercury within the ethereal field of Mars. The imprint of this field is on the 3rd ceiling. The ethereal field of Mercury is included with that of Venus within the ethereal field of Mars. The imprint of this field is made on the 2nd ceiling. rotation, axis of phases, compass moon, moon rotation. As we observe, there is a moon rotation from its center clockwards as the moon passes above us. The full rotation to our view from east to west is like this. Its rotation motion around its center happens on constant axis that we call the axis of moon's phases. In fact, we see the moon rotating because of its circle motion on constant axis above level Earth. In reality, this thing that changes is the angle that we are watching it, as it is moving, from rising till falling in the beginning and in the end of our visible horizon on the sky. Phases. The phases of the moon are changing the visible part of the face of the moon that we see with a rule. As it is getting bigger, we start to see from the side that there is our known world. As it is getting bigger, and when it is half, we see the half face of the moon. That is our known world. Here we can see the face of the moon in all of the moon's phases. As it is getting bigger, we can see Terra Vista land on the left here. When it is getting smaller, Terra Vista on the left remains visible, but our known world on the right disappears. Axis of phases. As the moon follows its path, it is rotating around its center clockwards, keeping its daily phase. This axis, the axis of phases, are always constant and stuck on the image of the moon that we see, the part of the face of the moon, and does not depend on the moon's rotation. Axis X. The moon follows this axis as it is moving on its path. Also is the axis of the moon's phase motion. Axis Y. This is the axis of visible phases. Also, as we will see, we can use this axis as a compass. Axis Y is aligned with magnetic north. To recognize the axis of phases, we have to see that axis Y is separating the known part of our world with the unknown Terra Vista, passing from the Atlantic Ocean, and axis X passes from magnetic north and from total center vertical to axis Y. Compass moon. We measure the angle between the vertical to the horizon line and the axis y. This angle is, for northern observer, the difference in degrees from south to east when the angle is minus. The difference in degrees from south to west when the angle is plus. For southern observer, is the same rule with opposite behavior. Finding the axis of phases x, y on the face of the moon, instantly we can use the moon like a compass in every phase of it, knowing in what direction we look at when we look at the moon. With this example, we can understand how the moon works like a compass in every of its phases. Here there is half moon, and as we can see our known world reflected on the moon's face. So, as we realize from this, the moon phase is half moon as it is getting bigger, first quarter. Also, we are further north than the moon's path. For examples, that we are southern, the rule is the same, but all are opposite. Motions of Sun and Moon. The Sun makes a spiral motion. This complex movement consists of two individual movements, a circular motion and a simple harmonic oscillation. The Moon makes a spiral motion too, but its center of the motion makes an oscillation too. Every new moon, the center of its motion changes. So we conclude that this is an elliptical spiral orbit. Simple harmonic oscillation. The circular motion is changing its radius as it follows a simple harmonic oscillation. For the Sun, the period T is T-Sun equals 365.25 days. For the Moon, the period T is T-Moon equals 28.5 days. Circular motion. The Sun makes 28.5 circles in 28.5 days. The Moon makes 28 circles in 28.5 days. So every day the Moon stays 12.8 degrees behind the Sun from the center of Sun's motion. Period of the Sun. T-Sun equals 1 day equals 24 hours. Period of the Moon. In 1 day or in 24 hours, the Moon makes 360 minus 12.8 degrees equals 347.2 degrees. In T-Moon, hours makes 360 degrees. T-Moon equals 24 multiplied by 360 divided by 347.2 equals 24.88 hours equals 24 hours and 52 minutes. That is why every day the Moon rises around 50 minutes later from the previous day. A complex motion results from the sum of two or more individual motions. In our case, we have a circular motion and a simple harmonic oscillation. The equations describing the individual motions, as well as the resulting complex spiral motion, are shown below. The motion of the Sun and the Moon are complex motions and are created by the sum of the individual motions. The component of the circular motion of the Sun creates day and night, while due to the component of the circular motion of the Moon lags behind about 50 minutes of the Sun every day, as the Moon has a longer period of the component of this motion. The component of simple harmonic oscillation in the recommended spiral motion of the Sun creates the seasons. The component of simple harmonic oscillation in the recommended spiral elliptical orbit of the Moon causes the Moon to rise and set every day from about 2 to 8 degrees northern or southern than the previous day, depending on the point of amplitude of the oscillation and the individual velocities that occur during the phases of the oscillation, where, when it reaches the extreme points, the speed is zero, while at equilibrium place the speed is maximum. Middle step of the spiral movements of the Sun, Bs, and the Moon, Bm. The Moon makes a full oscillation in 28.5 days. The spiral positions are 28.5 divided by 2 equals 14.25. The distance between the two extreme positions is 5,000 kilometers, and the elliptical orbit does not affect this range for each cycle. So the Moon is moving 5,000 kilometers divided by 14.25 positions equals 350.88 kilometers per day on the harmonic oscillation movement axis. Bm equals 350.88 kilometers. Sun. The Sun makes a full oscillation in 365.25 days. The spiral positions are 365.25 divided by 2 equals 182.625. The distance between the two extreme positions is 5,000 kilometers, so the Sun is moving 5,000 kilometers divided by 182.625 positions equals 25.378 kilometers per day on the harmonic oscillation movement axis. PS equals 27.378 kilometers. Note here that we find the middle step of the spiral. When the oscillation is at the extreme points, the pitch of the coil is smaller, while around the equilibrium position it is larger. Analyma. The spiral motion of the Sun and the Moon is obvious if we take the same photo every day exactly at the same time. What we see here called analyma and happens because of the complex motion of the Sun and the Moon. The duration of the Sun's analyma is equal with the period T-sun of Sun's harmonic oscillation motion. Sun's analyma duration 365.25 days. The duration of Moon's analyma is equal with the period T-moon of Moon's harmonic oscillation motion. Moon's analyma duration 28.5 days. Sun eclipse. Sun's eclipse happens only when we have a new moon. The Sun and the Moon are in the same constellation only every new moon. That means that they are in the same direction for the observer. The only thing that has to happen more than the Sun and the Moon is to be at the same circle of latitude during their own individual spiral motion. What is happening is Sun's eclipse phenomenon is essentially an overtaking of the Sun on the new moon. When we have a Sun eclipse, we can timing the duration of the phenomenon. Knowing the latitude that the phenomenon occurs from the date, as well as the duration of the phenomenon, we can calculate the overtaking distance, which is the diameter of the Sun and the Moon. Sun eclipse, standard condition. New moon, same constellation, same latitude. When the Moon and the Sun are going to happen as phenomena in the same constellation and in the same latitude, we have a Sun eclipse. The result of the conical refraction of the new moon is getting in front of that one of the Sun. When this phenomenon is close to this, we have a partial Sun eclipse. Moon eclipse. A prerequisite for a total lunar eclipse is to have a full moon. The Sun and the Moon are the result of the same cause, that is the cosmic field of energy that comes below from the Earth's surface in an upward direction. Depending on the angle of incidence of cosmic energy, we also have the phases of the Moon, as the conical refraction that creates the Sun plus acts as a limit to the conical refraction minus that creates the existence of Moon phenomenon. For the appearance of the lunar eclipse, as we said, the whole moon is a necessary condition. What happens is that when the two conical refractions are directly opposite and create the Sun and the Moon, but also when they occur at the same latitude, then the root of the conical refraction of the Sun, and not the result, the Sun-Moon, as in the case of the solar eclipse, is involved with that of the Moon frontally. So, as a result, we have the ever-increasing shading of the Moon. Essentially, we have the shading neutralization of the conical refraction of the Moon from that of the Sun. Moon eclipse, standard condition. Full moon, opposite constellation, same latitude. When the Moon is just opposite with the same latitude with the Sun, then we have a lunar eclipse. The root of the conical refraction of the Sun neutralizes the Moon's one. When this phenomenon happens close to this, we have a partial Moon eclipse. Separation of space and elements. The space is divided into two areas, the supermoon and the sublunary. In the space below the moon, the sublunary, there are the four known elements of nature which create a situation called by nature. The four elements of the natural state are earth, fire, water, air. These four elements interact with each other and are connected in pairs. Here we have a change of substance through birth and decay. In the submoon area, there is an odd situation in relation to the supermoon calm area. In the space above the circle of the moon, the supermoon, there is the quintessence of matter, the ether. Ether is a primordial element and is a source of power and creation, while follows the upper orbit, the celestial motion of rotation, like the constellations, because of the outer electromagnetic cosmic field. Atmospheric ratings. The atmosphere covers the entire submoon region. It is divided into atmosphere of the element of air and atmosphere of the element of fire, or in the homosphere and the heterosphere. In the atmosphere where the element of air is mentioned, all the heavier gases such as oxygen or nitrogen are mixed. Here the weather phenomena occur as well as the evaporation and liquefaction of water in water vapor. In the heterosphere, where it refers to the element fire, we have all the volatile gases of fumes and combustion, but also the noble gases as well as hydrogen. There is high energy and concentration here and zero humidity. All these gases are in layers and not mixed, with the densest being below while the thinner being above. In this part of the ionosphere is essentially where ionized atoms are located and high pressures and temperatures develop. Also here, there are the gases that cause daylight, giving luminosity as a reaction to the pilot electromagnetic energy and radiation of the sun. This fluorescence of these gases creates an umbrella under the sun, creating the daylight. Argon gives the characteristic blue of the sky, while neon, that reacts from far and with less energy, gives the colors of the sunrise or sunset, the yellow or red sky color shades. Water vapor is converted into water while fumes are converted into fire. Water vapor is in the homosphere while fumes are in the heterosphere. To emphasize, we have to say that ionization is a kind of fire. Thus, the heterosphere, there is a constant movement of gases which affects the atmospheric pressure per place. In the lower part of the heterosphere, we have contact with the atmosphere below. Lower gas streams from the homosphere help new exhaust and fumes to reach this area. These gases from fumes that rise upwards are very sparse and are called volatile with a high tendency to escape. In the submoon place, we have high temperatures due to the atmosphere and friction in contrast to the supermoon area, where high temperatures do not evolve.
We want you to come out. What's your name?
Celestial phenomena. In this section, we will explain various celestial phenomena such as comets, meteors, showers, falling stars, black holes, northern lights, starbursts, and finally meteorites and galaxy. For a better understanding of this subject, we will examine in detail the atmosphere, its layers, and the layers of space in general. What really happens as a result of this phenomena is essentially the weather phenomena in the upper layers of the atmosphere, ionosphere, as well as on the edge of the sublunary with the supermoon space. These phenomena are connected only with the elements related to fire. We are talking about the upper layers of the atmosphere, where the noble gases, hydrogen, molecular oxygen, etc., are stacked in layers. At the meantime, volatile gaseous fumes from Earth's surface are pushed upwards due to weather conditions of the troposphere and penetrate into these areas. We have the creation of gas currents in the ionosphere, where they carry the fume clouds even higher. Their saturation and combustion is depending on the size of the phenomenon, the space of the vapor cloud, the saturation speed, the saturation height, and other parameters which create these celestial phenomena that must be considered as results of visible combustion.
Songi bandeko ngai na makambo ona makambo unu para kileba kyuli balutua unu wenwe ona makambo
Meteors. Have you ever wondered where all the fumes from evaporating or combustion and volatile gases go? What is certain is that they do not mix with water vapor since they have nothing to do with the element of water. They are elements of fire and having a much lower density they escape to the upper parts of the atmosphere, unlike water vapor, where it is in the troposphere. But let's start from the beginning.
Fire from fire god. Fire from fire rod. Fire, you make fire mad. And if you make fire mad, hey, you gonna shout out for fire god. I'm gonna draw my fire rod. You make you know that it's a fire is mad. And fire is madder than mad. All over the world. All over the world. I say fire, fire, madder than Rudy's. A Rudy going to jail and won't come back from jail. Rudy's going to jail and won't get no bail. Everything Rudy do, then the Rudy gonna feel. Everything bad boy do, bad boy gonna feel. But bad boy going to jail and won't get no bail. Fire all over the globe. Chick a pick a say now. From fire riding pod. Fire come to burn up the bad.
There are two types of evaporation. A. The evaporation of water. B. Evaporation of fumes. In other words, we have an evaporation that concerns the element water, but also one that concerns the element of fire. Water evaporation refers to the water cycle where it occurs in the atmosphere along with weather phenomena. For a certain temperature, the atmosphere holds a certain amount of water vapor. When we have a maximum amount of water vapor, then the atmosphere is saturated, while if we have less vapor, it is unsaturated. All this is determined by the hydrometric parameters. Fume evaporation is related to the element of fire, is caused by the combustion of vulnerable materials, fossil fuels and fumes from the surface of the earth. These exhausts are responsible for changes in the atmospheric pressure. The fumes and all the chemical compounds after combustion are entrained by the gaseous currents, and as they are volatile gases related to the fire element, they rise upwards, passing from the air layer to the fire layer, going to the heterosphere, then to ionosphere, and finally on the edge with the supermoon area. This transfer of fumes takes place at a slow speed. As the fumes reach the highest point of the atmosphere, then they are entrained by gaseous currents that exist due to different atmospheric pressure and go down again condensed and ignite their friction with the atmosphere. Depending on the shape of the fumes and the saturation time of the mixture at the highest points of the atmosphere, different types of meteors are created. Depending on whether the fume cloud is long or wide, they appear with or without a tail. As for the scattering stars, falling stars and meteor showers, the cause is essentially the burning of saturated fumes that return down from the upper atmosphere. The formations of combustion and therefore the type of phenomenon depend on the quantity, quality, and predisposition of the combustion material that created the fumes. They are essential results of a visible burn. The element of fire is burned, and what we see is the flame that produced. All this reaction is occurring in a dry state. Ignition zone. The masses of fumes after their ascending course get saturated and start to descend. On the re-entering course in the atmosphere, they burst and we see these flashes into the night sky. Where they enter, there are low temperatures and fire is creating in a falling orbit. Also, there are cases where these fumes do not manage to burn completely. This happens when we have a large mass of saturated fumes that did not manage to burn completely due to the ingredients that may have been incompletely burned. If they do not burn due to the friction in the atmosphere that concerns the air as an element, then they can reach the surface of the Earth with the impact temperature being equal to the ignition temperature. After the impact, we have the conversion of the original material now into a solid body. The burning speed is big. The phenomenon is similar to the phenomenon of lightning, where we have ionization of the part of the atmosphere where it occurs, creating a discharge. Those saturated fumes that do not manage to reach the Earth's surface are burnt completely. They follow a parabolic orbit with a small slope to the ground level. The cause of all these phenomena is the evaporation of fumes into the atmosphere. As these fumes ascend from the layer of the atmosphere concerning the element of air, they take their place in the layer of the atmosphere concerning the element of fire, after first passing and entering for a while into the ethereal field above in the supermoon area. When they are at the level of the ethereal field, they follow the upper orbit like the constellations. When they are in the sublunary region, they move according to the density of the layers of the atmosphere. Transient celestial phenomena. Here we have the northern lights as well as chromatic formations like explosions or formations that look like holes. Their existence is due to the same reason as the shooting stars. Explosions with colors, not stars explosions. During the penetration of saturated fumes, heat returns from the boundary of the sublunar and supermoon places in the area of the atmosphere that concerns the fire, that is the ionosphere, ignites, and as a result of the visible combustion, we see those colors. As the composition of the fumes during combustion changes very quickly, these phenomena do not have a long duration. Black explosions, not black holes. As for formations that look like holes and gaps, they look like this because they emit cyan or black-colored combustion residues, which in black have zero lack of radiation. Aurora borealis. The northern lights also occur in this layer of the ionosphere. As the cosmic energy passes through the magnetic north from the bottom up, it ionizes these ionosphere layers. In those layers there are streams of noble gases where they are ionized in waves, something we observe as we see the northern lights. Comets. General. It takes a long time for a comet to appear from the moment that the previous one disappeared. Its height is not very large and has a small orbital width, likewise Mercury field. It has a circular orbit that follows the upper direction from the outer electromagnetic toroidal field. A comet stays longer than the stars in the sky and lags behind them until it disappears. It does not come close to the tropics and also never divides into pieces. They are not observed during the summer solstice. Having a tail or not depends on the location of the observer. The nearest points where the comet located, the easier to see comet's tail more clearly. Comets move in orbits outside the zodiac. Often they were observed more than one, while those seen without a tail were due to the disadvantage of observation. They do not depend on the motion of the planets that are ethereal fields contained in each other. They disappear without ever melting. Also, it has been observed that they happen the same time period with the earthquakes and tsunamis. They are never divided, being completely indivisible, and nothing comes in contact with them. Every encounter with another celestial body is purely apparent. Comets and weather conditions. The appearance of comets is combined with winds and droughts that favor the production and the movement of the fumes. Such weather conditions on the surface of the Earth favor the production of large amounts of fumes from the element of fire, making the atmosphere even drier. An amount of humidity in the atmosphere is broken down by these fumes and do not condense into water. When there is a dry climate and winds for years is when it favors the creation of comets. On the contrary, they are not observed when the weather conditions are different. Intense circular gas currents help move for the moving of these fumes up into the atmosphere. Comets appear outside the tropic circles because in the zone that the sun circulates, it breaks down these fumes before they reach the supermoon area. Comet's creation. Let us now look at the region of the atmosphere that has to do with the element of fire, namely the ionosphere, which is on the ceiling of the sublunar region. At the top of this area, dry and hot fumes are collected. The gaseous currents in the ionosphere, which cause various atmospheric pressures in places, carry upward new circular fumes currents to the point where the ionosphere touches the fumes layer. A part of the cloud of the fire vapor, fumes cloud, will be found at the boundaries of the supermoon and sublunar space, where an atmospheric thickening occurs and there is ignition. The combustion is not done either very fast nor too slowly. Nevertheless, it is strong and to a large extent. The shape of the comet depends on the shape of the fume cloud, if it was longitudinal or circular. So we have comets with or without tails. The material of the fire vapor that creates the comet is located on the borders of the supermoon and sublunar space. And sometimes it enters the supermoon ethereal place, entrained by the upper electromagnetic field direction, and remains formed for a period of time. Milky Way. Milky Way is in the boundaries of the supermoon and submoon space, or at the boundaries of the terrestrial and celestial worlds, borders the atmosphere that has to do with the element of fire, the ionosphere, high temperatures, ignition of fumes, electromagnetism, and ignition of noble gases. Above the supermoon there are the gradations with the toroidal fields, which are inside each other, which have their own motion and are called planets, but also the sea of fixed stars, which follows the upper direction of the whole ethereal electromagnetic cosmic field. The immovable stars in the sky that follow the above direction are ethereal concentrated reactions from the great depths of the oceans and energy spots of the Earth, where gushing cosmic energy by circular motion due to the geometry of the source, black sun below. In the ionosphere there is a lot of energy. Also there, the elements are separated by composition according to their density. The highest point is called the galactic zone and is on the edge of the supermoon. Galactic material is formed in the same way that the tail of a comet is formed. It is the burning of fumes that came from the surface of the Earth which took place at the upper limits of the ionosphere, and its remnants passed into the supermoon region. These remnants all accumulate together in the galactic equator, the Milky Way. That is why we see places in the sky only with stars, and somewhere galactic equator, all the fumes where they pass to the supermoon and follow the electromagnetic orbit of the outer toroidal electromagnetic field. The electromagnetic field that causes the motion of the ether does not affect the new fumes secretions, which separate and go to the same points on the galactic equator. We can see that the galaxy Milky Way is a big comet tail that gathered to the galactic circle on the galactic equator that is electromagnetically connected with the electromagnetic direction of the outer ethereal field. Biogeochemical cycles. There are 4 biogeochemical cycles. All of them have 2 directions that they become two-way. All functions and all life are created due to those 4 biogeochemical cycles. Fire, biogeochemical cycle of oxygen. Air, biogeochemical cycle of nitrogen. Water, biogeochemical cycle of water. Earth, biogeochemical cycle of coal. A. Water cycle. This cycle is very well known to us. Nevertheless, we are able to observe the surface water, but not the deep groundwater currents. The spiral motion of the sun creates the seasons, as well as the different temperatures which they cause the movement of gas masses, and also the evaporation and condensation of water respectively. This cycle is in equilibrium because not all water can evaporate, nor can all vapors liquefy. The other three elements and their biogeochemical cycles contribute the same way to the continuous evolution of birth, wear, and regeneration. B. Carbon cycle. The carbon cycle is the biogeochemical cycle in which carbon is exchanged between the atmospheric layers, also exchanging the geological formation of the Earth. Earthquakes and volcanic eruptions are in this cycle as they are combined with the release of carbon dioxide from the Earth's interior into the atmosphere. Carbon is the main component of biological compounds as well as an important component of many minerals. Along with the nitrogen cycle and the water cycle, it includes a sequence of events that are key to making the Earth capable of sustaining life. This cycle involves the movement of carbon as it is recycled and reused throughout the troposphere. It also includes the long-term processes of its capture and release from carbon tanks. Oxygen is the second most abundant element in the atmosphere after nitrogen and the second most abundant after hydrogen. In this sense, the oxygen cycle is related to the water cycle. The oxygen circulation involves the production of two atoms of oxygen, O2, or molecular oxygen, O. This is due to the hydrolysis during photosynthesis carried out by the various photosynthetic organisms. O2 is used by living organisms in cellular respiration, creating the production of carbon dioxide, CO2, the latter being one of the raw materials for the process of photosynthesis. On the other hand, the photolysis, hydrolysis activated by solar energy, of water vapor caused by the sun's electromagnetic energy occurs in the upper atmosphere. Water decomposes, releasing hydrogen which is lost in the atmosphere, and oxygen is incorporated into the atmosphere. When an O2 molecule interacts with an oxygen atom, ozone, O3, is produced. Ozone is the so-called ozone layer. Oxygen is also an essential element for combustion, and that is where the connection of this element with the cycle of the element of fire is. A lot of oxygen is stored in the earth in the form of metal oxides, and this cycle is also associated with the element of earth. Plants create oxygen. Phytoplankton create oxygen. Stored oxygen in the oxide minerals of the land. Oxygen used by animals, plants, bacteria, fire, decomposition and oxidation of metals. Oxygen made from photosynthesis by plants on land and phytoplankton on the ocean surface. Oxygen from the sun made in atmosphere when sunlight breaks down water. D. Nitrogen cycle. The nitrogen cycle is in the process of moving nitrogen between the atmosphere and the biosphere. The nitrogen cycle illustrates the relationship between different forms of nitrogen in the soil, water, air, and living organisms. It is considered to be a cycle because nitrogen is always present, no matter if it changes different forms or goes from one place to another. The nitrogen cycle is one of the most basic and relevant biogeochemical cycles. It is an important element since it is required by all organisms for their growth. It is part of the chemical synthesis of nucleic acids and proteins. largest amount of nitrogen in the world is found in the atmosphere, and it is called atmospheric nitrogen, N2, which cannot be used directly by most living things. There are bacteria capable of repairing it and incorporating it into soil or water in ways that can be used by other organisms. Nitrogen is then assimilated by autotrophic organisms. Most heterotrophic organisms acquire it through food. They then release the excess in the form of urine, mammals, or feces, birds. In another phase of this process, there are bacteria involved in the conversion of ammonia into nitrates and nitrates that are incorporated into the soil. And at the end of the cycle, another group of microorganisms uses all the oxygen available to nitrogen compounds in the breath. In this process, they release nitrogen back into the atmosphere. Currently, most of the nitrogen used in agriculture is produced by humans. This resulted in the excess of this element in soils and water sources, causing an imbalance in this biogeochemical cycle. Nitrogen fixation. Nitrogen fixing bacteria. Nitrifying bacteria. Dendrification bacteria. Dendrification. Ammonification. Assimilation. Underground water production. Water that has evaporated due to sunlight and high temperatures descends with the phenomenon of rain or snow and accumulates in the soil. Some of this water creates rivers, but there are two types of rivers. A. The ones that are seasonal and their flow fluctuates. B. Those that are constantly flowing. Some of this water enters into cavities. The size of the cavity that accumulated water inside the earth creates these two categories. If it is large, then it accumulates more water and does not manage to run out before the new rains. If it is small, then it creates a seasonal river, since when this tank empties, the river dries up. For the case B, springs and rivers occur at a much higher rate for another reason. All this water is stored inside the earth, but not only in cavities or in places that act as reservoirs. The whole earth would not have enough space to hold all this water. In the same way that we have the creation of water in the air of the atmosphere, we also have the creation of water in an underground water cycle inside the earth. As we have condensation due to cooling in the atmosphere, the same process of condensation takes place inside the earth where cold prevails. This underground condensation and the creation of underground water takes place continuously and takes place inside the earth, creating droplets, gushing water, and finally springs. The earth produces more gushing water and has more springs in the mountains, while we would say that altitude is a necessary condition for the creation and existence of a spring, since it is not common to find springs in lowland places. This is because of the mountain's function. It is like hanging sponges that collect water. The highest points at altitude receive the most groundwater, while the flow of gushing water is constant and comes from many different places, having a specific flow from each one. Underground rivers. The sources of the rivers are not due to specific pits of the soil. The space of the whole Earth would not be enough to hold the storage of this volume of water. Also, it would not be possible to find so much water to supply all these rivers with a constant flow. What mainly happens is the underground water cycle. At the foot of the mountains, we start to have springs because there slowly begins the cycle of creation of groundwater, creating cavities and gaps with stored water. These cavities can be small or large, and when they receive more water inside the earth, they grow, pushing the subsoil down. Rivers originate from springs that are at altitude, and these are continuous flow, having water from the underground water condensation cycle. Many rivers become underground at intervals, and they are swallowed by the earth while then flown again outside the ground to another point. There are also many underground rivers that flow inside a mountain underground to another place where they become rivers on the surface of the earth. Examples of this type are some rivers in Asia such as Bactros, Jaspis and Araxes, as well as the Indian River originate from groundwater where they come from mountains located in Greece. The Caucasus feeds many rivers that are quite far away as the Feiss, and the mountains of the Black Forest in Germany feed the Danube and Rhine. So we see that just as there are rivers on the surface of the earth, in the same way there are underground rivers inside the earth that can go very far. A prerequisite is the altitude, since there the underground water cycle works, making the rocks of the mountains like a sponge, gushing the water that produced underground. The rocks of the mountains have a very dense texture, and also there is a cold climate, so it favors the condensation of water in the underground water cycle, so this water is slowly stored and then rises and becomes a source. The lower altitudes are composed of rocks which are, as we said, porous, limestone or clay, without being able to hold water. Inflow lakes. The appearance of such a lake is found on a small scale but also on a large scale. An example of such a lake is the Caspian Sea, where many rivers flow but at the same time the level does not rise and there is no outflow on the surface. Also, the Caspian Sea is not connected to a single and continuous sea. In these cases, the water accumulates underground, creating streams of cold water that flow down while the warmer and salty water remains up. The water is stored below the surrounding area underground, around the greater depth of the lake. The amount of water in the lake remains the same, its depth is very large, while there are sources of fresh water inside the lake in shallower areas. as a living organism. The wet or dry climate that exists in places changes depending on whether new rivers are created or whether the existing ones have dried up. Apart from the rivers, the sea is also changing. Areas that are sea were dry, and areas that are land were once sea. This phenomenon follows a regular periodicity. This is because there is a basic principle followed with which the interior of the earth functions, works in a similar way as the plants or animals. In other words, it has periods of young and periods of old age. Only in contrast to plants and to animals, these changes do not concern the whole body, Earth, but local continents and regions. Independent areas go through a period of young or old age, going through all the stages. The reason is that some areas heat up a lot, others a little, and others not at all, fact that generally changes. This is because we have the movement of the magnetic north, which as it moves takes with it the climatic zones created by the movement of the sun centered on the magnetic north. So each part of the earth has a different dynamic in terms of how old or young it is. For example, we have the aging of an area during its drying, since it entered a warmer climate zone due to the movement of the magnetic north. Also, as rivers are lost and new rivers are created, the shores of the seas are shifting. Lakes and water areas are transformed into marshy areas, which in turn are turned into fertile valleys and then into dry areas. The geological changes that affect the evolution of these natural phenomena occur very slowly and gradually. The time it takes to perceive these changes is enormous, and so it is not perceived by humans to realize these changes. A complete cycle of these changes throughout the Earth has a period of 26,000 years, a period of time also called the Great One Circle, the celestial year. During this time, the magnetic north makes a complete rotation, carrying with it the climatic zones, creating in different parts of the Earth different soil dynamics in terms of youth or aging, because the geology of individual soils is affected by those of climate change. To think about how gradually these changes take place is enough to think about the time it takes the whole process for a complete cycle. Ground epochs. As the magnetic north moves and takes with it the climatic zones, it creates seasons for the soils all over the earth. So there are areas where at the moment they have soil season in spring, summer, autumn and winter. What season each ground will have has to do with whether the magnetic north passed through there or whether it is going to pass in the future. Also, at what distance is it from the circle where the magnetic north turns. Ground epochs are making every ground different, and they are repeated every 26,000 years for the same place. So, each place has its own different soil season. Glaciers and floods do not occur in the same places because the magnetic north is moving, making the big cycle, taking with it the climate zones. Floods and glaciers last a long time for one place in the big winter of the ground epochs, and feed the soils to become sources in the future when this ground being spring around epoch and weather conditions become good again. Also, it is not possible for an area to have the same presence of the liquid element for a long time. In conclusion, these geological changes, after a long time, change all the areas from land to sea and vice versa throughout the Earth. Thus, each ground goes through all its seasons and situations, making the terrain of Earth changing at a very slow speed. We live in a bigger world with hidden continents. Some of them have a good climate for living and some others do not. Climate conditions are changing because of the motion of the magnetic north that takes with it all the climate zones.
On the night of the tiger moon, Jaguar God, bury me in jade, cover me in amber. On the night of the tiger moon. Tiger moon. fresh air. Tunnels hover over three-dimensional freezing zones. Hypnotic regression. The cult of resurrection. On the night of the tiger moon.